Hello, everyone. We're gonna talk about our technical survey about content-based image retrieval. This presentation will be divided into four parts, which is proposition, fundamental question, development process, and some challenges and ideas. First, I'm going to talk about proposition. So the CBIR problem was originated from TBIR, which is first proposed by Josh Smith in 1970s. However, it requires excessive manual annotations. So now in 1990s, we propose this CBIR problem to solve these annotation problem. So there's multiple applications of CBIR. One of the most common one is image search engines, and it was also used in medical imaging and landmark retrieval. Next, I'm going to talk about a fundamental question. The framework of CBR was like this. It includes the feature extraction from the database and the query image, and finding the similarities between the features and return the sorted images. So one of three of the most key parts of this framework is the feature extraction, feature representation, and similarity measurement.
So now I will introduce the development process of CBIR. Before 2012, we used traditional methods to do the feature extraction, but after 2012, we have CNN-based models, so we used CNN models to do the feature extraction. And there are different methods for feature extraction, feature representation, and similarity measurement. So in our presentation, I will introduce some different methods for feature representation. The first method is called locality-sensitive hashing. In LSH, the core idea is that when two neighboring data points in the original data space are mapped using the same hash function, the probability of these 2 points being still neighboring in the new hash space is high, while the probability of non-neighboring data points being mapped to the same bucket is low. With this approach, we can easily find similar data within the same bucket. And the next method is called bag of features, which has come from the bag of words. We do feature extraction, feature clustering, feature encoding, and feature representation in this method. So first, the local features are extracted from images using techniques like SIFT or HOG, and the extracted features are clustered using algorithm like k-means to create a visual vocabulary. After that, we use the local features are matched with the visual vocabulary to compute their frequencies or weights. And then last, the frequencies or weights are combined into a fixed length vector representing the image's features. And the next method is called the vector of aggregate locally descriptor. In BOF, the count of local feature is accumulated onto the corresponding cluster centers, considering only the frequency or weights of the features. But in VLAD, it accumulates the deviations of local features from the cluster centers, taking into account both positive and negative differences. Moreover, VLAD typically accumulates the deviations for the k-nearest cluster centers rather than just one. And the last method is called spatial pyramid matching. Since the bag of words model completely lacks spatial position information, it significantly reduces the accuracy of features. The spatial pyramid matching addresses this issue by adding spatial position information to the BOW model. Essentially, SPM incorporates a multi-scale approach on top of the BOW model. And in our presentation, we offer some challenges and ideas. So nowadays, we have a lot of large-scale databases, and we need to improve the speed of the retrieval method. And also, we need to balance intra-class diversity and inter-class similarity. And then we can also add some feedback techniques into the CBR models. Thank you for listening.